So in this problem, as we seen in the previous problem, similar is given. That is, you have to plot the Bezier curve having endpoints P0. That is the initial point of the starting point of the curve, and the end point is a P3. So it is a quadratic Bezier curve. So 7, 0 is the end point, and other control points are P1, 7, 0, and P2 are 7 and 6. To plot the values for u, that is from 0 to 0.1, 0.2, 0.3, and so on to up to 1. Okay, and we are considering that as the sequence from P0, P1, P2, and P3. So first of all, we have to write the given data. That is, it is a quadratic, so n equal to 3. Okay, P0, 0 and 0. Then P1, 7 and 0. P2, 7 and 6. And the endpoint P3 is again 7 and so these are the points given to draw the curve. So you have to find out the by using this matrix. So our formula is P of u equal to u into b. So u will be, this is a quadratic cube, n equal to so just starting u cube, u square, u and 1. This will be the value for u. Then mb, from the derivation we have found out that -1, 3, -3 and 1. Then 3, -6, 3 and 0. Then -3, 3, 0, 0 and 1, 0, 0, 0. Okay, and you have to write out that position. So first initial position P1 is 0, 0. Then sorry, P0 is 0, 0. Then 7 and 0. Then 7 and 6 and 7 and 0. Okay, so now you have to multiply this and you have to find out two equations, that is for Px of u and Py of u. Okay, so for that, first u cube, u square, u and 1, then multiply the row and column multiplication will be there. And you have to convert this 4×4 matrix into 4×2 matrix. First -1 into 0, 0, 3 into 7, 21. I will increase the weight of column. 3 into 7, 21. Then -3 into 7, -21. And 1 into 7, 7 plus 7. So next, for the second answer of this row, -1 into 0, 0, 3 into 0, 0, -3 into 6, -18, -18. Okay, then 1 into 0. Then again second row, first column, 3 into 0, 0. Then -6 into 7. How much it is? 42. -42. Then 3 into 7, plus 21, then 0. Okay. Next, second row, second column. So you will get 18. Then next, minus 3 to 0, 0, 3 into 7, 21. Okay. Then for last, all answers. This will be 0, and last was 1 to 0, 0, and this will be also multiplication. Now, after this, we can write for two equations. Again, I will write this u cube, u square, u and 1, and rewrite this matrix. So, it is 7, then it is 1, and this will be minus 18. Then this will be minus 21, 18, 21, 0, 0, 0. Okay. Now, what will be the equation for px then? Px of u. So u cube into 7, 7 u cube minus 21 into u square, and u plus 21u. So this will be the first equation. Okay, for y minus 8 u cube and plus 18 u square. So again, there will be no any other. So these are the two equations. Now we have to find out the values of the curve from varying from 0, 0.1 to 0.3, 0.4, and so on. So in this way, you can use the tabular form for the answers. Okay, then this will be u ex of u p y u. Okay, then for 0 you have to find out for 0, then 0.1, then 0.2, then 0.3, 0.4, 0.5, and 0.6, 0.7, 0.8, 0.9, and 1. I will directly write the answer. So in this case, for x, you have to use instead of u, you have to use 0 for the first. Then for next one, 0.1 in the equation number 1. Suppose this is your equation number 1. This is equation number 2. In this way, you have to find out the answers. So this will be 0, 0, then 1.8 something, 8, 9, then 0.6. So in this way, you have to complete all the points. I will write directly 3.4, then 4.5, 1.13, then 5.4, 1.72, so 6.1512, and 2.25, 6.55, and 2.559, then 6.881, and 6.4, then 6.9, and 2.30, 6.99, 1.458, and 7 and 0. Now in the examination, you have to solve all this and you have to plot the graph. So for that, you can use a graph paper, or you can just create a graph. So the maximum point is, I think, 6, 7, up to 7 it is. So you have to increase this one to you have to plot that up to 7 in x and y, and from that point, from 0 0, starting from this here, this point, then point 1 point. Okay, in this way you have to plot all the points. You have to plot all the points in this way. I think so the curve comes. Okay, so I'm not using that. You can use the last page of your answer sheet. There is a graph, you can use that, and you have to refer that that graph is plotted over there, or you can directly use in this way also. Okay, so I will give you another example of similar kind of for the homework, and then other type we will solve. That is for a cubic curve or a Bezier curve. First of all, I will give the example for homework. Homework example. You have to try it at home. So same P0. I will directly do the points P0, 2, comma 2, comma 0 raised to T. So in this way, you have to use only these 2 points. Okay. If it is given 3 for Z also, you have to use only these 2 points, 2 and 3. Then P2, 3, comma 3, 0, and P3, 3, 2, 0. Okay, in this way, for in starting point is a 2 2, x is 2 and y is 2, and P1, that is the control points are 2 and 3 and 3 and 3, and the end point is 3 and 2. So, and it varies the curve points from u equal to 0, then 0 0.25, 0.5, and 0.74. For example, only 4 to 5 points you have to is given. All this will 9 to 10 points are not given. Only 5. This kind of problem will be asked for the examination. As there is a time restriction, they will give you maximum 5 points to solve to plot the curve. Okay, so this will be your homework problem. I will wait for 30 seconds and we will start the next problem. You can write down this or take a screenshot. Now the next problem is over a cubic spline of Bezier curve. So instead of the values, they have given you an equation, and you have to use that equation, and you have to find out the final answer. That is the equation for P0 and P1, P2, and P3. Okay, so let's move to the next problem. Okay, so a cubic line is represented by the following equation. So in this case, equation that is P of u equal to P3 u cube plus P2 u square plus P1 u plus P0, where 0 is less than equal to u is less than equal to 1. Okay, so where C0, C are the polynomial, this C3, C2 are the polynomial coefficient, and you have to determine they are asked you to determine the four control points. Okay, find out the four control points of Bezier curve, of Bezier curves. So instead of using the matrices, you can use the equation of for the Bezier curve, as I taught in the derivation. That will be much easier to solve such kind of problems. So let's begin with the problem. So P of U, the equation, instead of the matrix, I will use this P0 1 minus U cube plus 3 P1U in bracket 1 minus U square plus 3 P2 U square in bracket 1 minus U plus P3 P3 U cube. Okay, so this equation. So this equation can also be used for the previous problem also, but it consumes more time. So instead of now, you have to use for such just when the equations are given instead of the points. Okay, then P0, I'm splitting this 1 minus 3U plus 3U square plus U cube. Okay, so this cube bracket is split. Then plus 3P1U, then 1 minus 2U plus U square for this. Then plus 3P2 U square minus U cube, U square minus U cube plus, I just multiplied this, okay, U square minus U cube, and last P3 and U cube, P3 and U cube. Now you can also multiply this inside, then you will get U. I will use again step again 1 minus 3U plus 3U square minus U cube, or you can directly multiply this P0 inside. I will rewrite again. U cube I will take common, and minus P0 plus 3P1 minus 3P2 plus P3. Okay, and U square. So in that U square which are common, so 3P0 minus 6P1 plus 3P2, and for U minus 3P0, next plus 3P1 plus P0. Okay, if the equation curves represent identical cubic spline curve, and then this will I will consider as C3, then this will I will consider as C2, this will as C1, and C0 equal to P0. Okay, so write that if equation curve representation and identical cubic spline, then we can write down C3 equal to this bracket minus 0 plus 3p1 minus 3p2 plus p3. Okay, so I will write down, suppose this is equation number 1. Then substitute 3p0 minus 6p1 plus 3p2. Equation number 2, c3 equal to minus 3p0 plus 3p1. This is equation number 3, and last c0 equal to c7. This is equation number 4. Now substituting this equation, we have to find out the values for p1, p0 and all. For that you can directly you have get this answer as p0 equal to c0. I can write down again p0 equal to c0. Okay, then to find out the p1, you can substitute the equation number 4 in equation number 3. Equation number 4 into 3, we will get this c1. Sorry, this is c1. Okay, c1 equal to minus 3. Instead of p0, I will write c0 plus 3p1. Okay, and if I convert this p1 equal to 1 by 3 c1, 1 by 3 c1 plus c0. We will get this answer for p1, point number first control point. Get this answer. Next, to get p2, I will use this p1 and into to find out the values. Okay, so I will use this equation, this answer into C2 equation. So C2 equal to 3. So instead of P0, I will use P0 minus 6. P1 value is 1 by 3. 1 by 3 P1 plus P0 plus 3P2. 3P2. So after solving this, we get P0 minus 2 P1 minus 6 P0 plus 3 P2. Okay, so this will be the equation for. Now we have to find out the P2. So for P2, you can change this. P2 equal to 1 by 3 C2 plus 2C1 plus C0. Again, the step in between this will be I will change all this C0 minus in here minus 2C1 plus 3P2. Then you can easily convert this. Okay. Now to find out the P3 point, I will use this equation for P1, P2 and P0 in the equation, that is for C3 equation, that is minus P0 instead of minus P0 plus 3 bracket 1 by 3 C1 plus C0, then minus this C2 plus 2C1 plus C0 plus P3. Now just minus 0 will get cancel, then we'll get plus C1 plus 3C0 minus C2 minus 2C1 minus 3C0 plus P3. Okay. Now after cancelling out this is non, and Okay. And C0, this become C1, this C2 also, C2 will remain as it is, it will be become minus, and then C1 will become this and this, and C1 plus C3. So you can write down P3 equal to C3 plus C2 plus C1 plus C0. That will be the answer for the last point, the last control point. Okay, so we have found out P3, P2 over then P1 and P0. So in this way, if the equations are there comes to solve instead of the points, you can use this instead of matrix. You can use this equation to solve it. So I'll come back to the presentation. Okay, so we have seen what are the explicit, implicit parameters of and approximate derivatives. What are the approximate derivatives, interpolating derivative? What is the difference between them? Then we have find out the derivation, this matrix on the derivation. Then we solve the problems over here. The next curve or the spline is a B-spline curve. So B-spline curves are is a uh, is a generalized form of a Bezier curve. So they are similar to Bezier curve, but the only difference is that the curves are defined with the help of characteristic polygon, and the advantage of this B-spline curve is that due to its ability to control the curve's shape uh, locally as opposed to global control. So this is done by using blending function. So for your portion, this Bezier spline curve problems will be not there for the B-spline curves. Only the problems will be asked for the Bezier curves. But what are the B-spline curve? I will show. Okay. Okay. So the original curve. Suppose this is the original curve. In this way, I'm just using it. Now this is the original curve with the control point. Suppose here is a control point, then here is another control point. Here is also a control point, and this is the control point, and over here is a control point. So this is the improved version of this curve. So in which the advantages of a B-spline curve, is that it is independent the number of control points. Okay, as compared to the four control points generated through the cubic Bezier curves. And in case of B-spline curves, we can generate a linear also, quadratic also, or a cubic curve. Okay, suppose this is the original curve there. Okay, and these are the control points. Suppose this is P0, this is 1, this will be 2, P1, okay, this will be P2, this will be P3, this will be P4, P5, and the end point is P6. Okay, so in this you can modify the control points can be possible in this case, and both curves. Suppose this is the curve, and modified curve is in this way. In this way. Uh, in this way, suppose this is the modified curve. uh, then we can merge also. Merge both the curves, and we can create a superimposed curve in case of B-spline curves. Okay, so beside the local controls of B-spline curves, will allow the control points without changing the degree of polynomial. So polynomial degree, suppose it is n equal to 3 is there. So it will allows to vary the control points, but this n value will not change. Okay, and most of time these spline curves are widely used because of its better control over the more complex. Well, if the complex are there, curves are there, they are if the curves are more complex, then these line curves are most preferred in case of surface modeling and other. Okay, so in the next lecture, we'll see. I will just give you some. We'll see what are the algorithms used for Windows and viewport clipping algorithms. So what are the window and viewport clipping means? The trim option used uh, in CATIA. I'm using one software that is called CATIA. Suppose this is suppose this is there. This polygon is there, and I don't want. I want only this, and for that I can use the trim option and remove these 2 points. So this is nothing but the window and viewport clipping algorithm. So in that we will see what are the point clippings are there. Then Cohen-Sutherland algorithm for line clipping, and for polygon clipping, it is used the Sutherland and Hodgman algorithm is used. So we will see what windows they use for clipping, and what algorithm used for point, and then the line clipping algorithm, and then we'll see the Cohen-Sutherland line clipping algorithm, in which this 100 what it means, 100 what are this, and how to solve the problems over this Cohen-Sutherland and line clipping algorithm, and also the problem over the polygon clipping algorithm. That is nothing but the Sutherland-Hodgman algorithm, in which you can see this just clipping left edges. So inside the box only. So there are one, two, three, four stages are there. So in the first case, suppose the star is there. So in this first clipping, the right edge will be clipped. So you can see over here, light. I will just and you can see this in the first case of flipping the right edge. So this right edge is removed over here, and then next the top edge is gone. Okay, top edge is gone. Then the next one is the bottom edge is gone, and inside the window, remaining portion will be a polygon. So this is the polygon clipping, and in case of line clipping, uh, the line which is inside this box will remain, and the other will be get trimmed. Algorithms and derivations useful for this, or what are the conditions are there for the Cohen-Sutherland and line clipping? We will see, and we will see the problems over this line clipping and line clipping. So most of all, point clipping problems we will not ask. A line clipping problem are most widely used, widely asked in the examination, and rarely this polygon clipping problem should be asked. So We'll see in the next lecture on that is I think on Saturday. Okay, that will be your last part of your this second unit. So first two units are shorter. Uh, there will be a manual part programming, then various codes. Codes will be the G codes and N codes, that is preparatory code and machinist codes. We'll see. So it will take more time, consume more time in that unit number 3, and then the EFT unit also there. It is also time consuming because in that syllabus you can see that. We'll open that syllabus first. Yeah. Then okay. So in this we have seen now uh, the equations and applications for the Bezier, and we solve the problems over this. What are these kind curves? So mostly, what advantages of these kind curves are asked, and this surface and solid modeling advantages and limitations will be discussed at the end of this topic. The only part of the numericals on this topic remaining is the window and viewport clipping algorithm and the problem over line clipping and polygon clipping. Then after this, in the third one, because uh, manual part programming will be there. So what is the point-to-point and straight line, considering some theoretical parts related to part programming. Then it involves also the APT programming. So this will also covered in your NP3 subject also, but I'm taking the problems, simple problems to the subroutine problems over this part programming. So it will consume more time. Sorry. And for this FEA also, they have mentioned 1D, 2D, and 3D problems. So 1D problems, there are combinations of bar element, then the trusses are there, then beam elements are there. So three elements we have to cover from this 1D. Then 2D problems, 2 to 3 types are there to solve, and 3D problems is axisymmetric problems will be there. And they have mentioned also the thermal analysis part. So heat transfer problems will be also there. And we have only 30 lectures. So I think this will be this is our sixth or seventh lecture is there. So I will more focus on these two topics, and then the remaining two topics will be 5 and 6. Is mostly of theoretical part, and I will cover this FMS in the practical session by using Flexim software. And that's all for today. We'll meet on so over this problems of window and viewport clipping. Okay. So any question regarding to the session? Any question regarding to the session? We have to practice this two to three problems over Bezier curve. So it is for 100% asked in the examination. This such kind of problem. Okay. So any question? Any questions regarding to this session or problems? I think I have covered all types of Bezier problems. So mostly it is of only two types, 2 to 3 types are there. So I covered that problem.
Excuse me, sir. हेलो
हेलो
हाँ सर आपने जो नो, इसके ऊपर जो प्रॉब्लम सॉल्व की है वो हमारे साथ शेयर कीजिए ना सर। पिछले बारी
हाँ मैं
पिछले यूनिट की भी हमें पीपीटी नहीं मिली अभी तक।
अभी मैं क्या करता हूँ, पहले यूनिट का और सेकेंड यूनिट का भी कुछ शेयर करता हूँ। देन ये जो प्रॉब्लम है ना, इसकी इमेजेस लेता हूँ और ये वाली भी शेयर करता हूँ आपको, जो इसमें पर ये कैसा रफली यूज करता हूँ। तो मैं एक्चुअल जो नोट्स है मेरे, I will use that and convert into PDF and I will share that. Okay, that will be fine
हाँ
for
सर,
you.
चलेगा चलेगा
But
सर,
this is
शुक्रिया।
not, I think, these are not in that PN Raw book. I will share this, and you can refer the PN Raw book for CAM and for CAM and for means third unit, and for first and second unit also it covers most of it. But for FE, you have to use another book that is, I will tell you tomorrow the author name. That is very a good book over that, in which all the topics are covered over that unit 4. Okay.
चलेगा सर, सर शुक्रिया सर।
Thank you for listening to that. I will first take your attendance, then you can leave.